Today is International Tap Wrench Appreciation Day. To commemorate, I thought you and I could bring a new one into the world. Together. Let's make a copy of this tap wrench here. These are two of the 4, maybe 5 tap wrenches that I own. If you're the sort of person that enjoys judging a book by its cover, you may come off with the impression that tap wrenches are simply for holding taps. And in this particular case, you'd probably be about 90% correct. But they're also good for screw extractors or hand reamers. I use them a lot for adjustable hand reamers. But anything with a square drive on the back, I think is probably fair game. All tap wrenches are beautiful, just some happen to be more beautiful. Case in point, this is probably my favorite right here. This is a Starrett 91B. New, I don't think they're all that expensive. I mean, the Starrett name usually sets you back a couple extra bucks, but you can find these used on eBay almost every day of the week. It works great, it's a pleasure to use, feels wonderful in the hand, just an exceptional heirloom quality tool. That said, and I couldn't tell you why exactly, 9 times out of 10 when I need a tap wrench and I open the drawer, I use this one here. Now I had the smaller Starrett. There's a smaller size than this for smaller taps. I have it around somewhere, but I broke the locking pin on the inside. It's got a little V pin. As you turn that, clamps down on the square end of the tang of the tap or the tool that you're using. When that one broke, it somewhat scarred me emotionally. So when I use this one, I'm a little bit more careful about it. Just because I can open this up to accept a 1/2 inch tap, I try to be a little bit more reasonable with this tool. Anything bigger, within its capacity, I reach for this one. I don't remember exactly where I got this. A garage sale maybe, or I found it in an old toolbox. What I do remember is it being in pretty bad shape, cosmetically, and having to clean it up. I threw it in with my other wrenches, and with time, I don't know, I suppose I have taken a liking to it. Except, there's 1 or 2 things I don't quite like about it. A few details I think are a little bit off. They're subtle, and I'd like to make another one, but with some of those small changes incorporated. If you'd like to follow along at home, I'll add some drawings to the end of this video. I plan to eyeball the build based on this tool and what I think I'd like to change, then take those dimensions and share them at the end. The only thing you need to do is figure out how to print a video. Now, skill level for this project is pretty low. I'd put it at about a 1. Tools you'll need? All of them. This particular specimen appears to me to be homemade. Maybe a school project, apprentice project, or someone just wanted to make their own. Homemade tools have a certain air about them, and this one screams homemade to me. That and the knurling is pretty weak. I don't believe that's worn down. I mean, you'd have to do a heck of a lot of tapping to wear knurls down this far. It looks like someone just figured it was good enough and stopped as soon as they saw the pattern start to develop. Or maybe it's a result of some combination of a hard steel and a light lathe. I don't know. Also, the handles were turned between centers. There's a center mark in there and a center mark on this end. You might not usually see center marks on mass-produced tools, or at least not centers this large anyway. Come to think of it, maybe that's why the knurling isn't very deep. That's potentially a lot of side load to put on centers, but I'm getting ahead of myself. This wrench is made up of 2 sets of 2 identical parts. There are 2 handles and 2 jaws, both of which are identical pairs. The jaws have 2 holes in them. One is a slip fit for the handle, and the other is threaded. There's a V-groove, of course, too, that provides the clamping geometry. And again, they're exactly the same. So when you flip one, insert the handle through one clearance hole and into the thread. The other does the same thing. Each handle threads into opposing holes, clamping the jaws and holding your tap. First thing you should always do, whether you're looking at a part or a print, is think through the order of operations. We need a game plan to make this part that won't come back to bite us in the butt. It's not that hard to paint yourself into a corner, where you're maybe 90% through your part and can no longer hold on to it or fixture it properly to do the rest. For example, in this case, my first inclination is to generally rough a part out, then come in and finish the details. But let's say we cut this to length and rough in the diameters and the taper, kind of turn the overall form. We might run into a problem cutting the threads, since the middle is now tapered and difficult to hold onto. Same, of course, would go for the knurls. With this long taper now in the middle, we have something of an awkward part to hold onto, to clamp onto, to do the rest of the features. So I think I'm going to leave this cylindrical for as long as I can and come in and likely cut this taper last. I don't think I need that center in the threads, but I may still need a center in the back. I'll try to make that as small as I possibly can. I've got a piece of steel in the lathe. There's a long piece in there, more than enough to make this handle. In fact, I'll probably make 4 of these. And I plan to start with the threaded end. I'll basically cut the diameter down to this shoulder, then cut a reduced diameter for the thread, and finally cut the thread in. This way, with longer stock, if I make any mistakes here, I can just move backwards a bit on the stock. Had I cut this to length, if I made a mistake, I'd have to throw away the whole part and start over again. And there it is, one side complete. I opted for slightly finer threads, and I just chased them on with a die. It's one of these things. Now you can do that any way you like, single point it, double point it, triple point it. I just wasn't in the mood today. If you've got a nice sharp die on these smaller diameters, just run it on, run it off, and move on with the project. Just be sure you turn this the right direction lest you end up with left-handed threads. Quick tip though, to get these things cutting well, chamfer the lead in and reduce the diameter by about 10% of your thread pitch. So for example, this is 3/8 16. So I turned this entire section to 3/8, and the part I wanted to thread with the die, I dropped by 10% of that thread pitch. So this is 16, the pitch would be 1/16, that's 0.0625, 10% is 6 thou. I reduced this diameter just for the length of the thread by 6 thou. Same thing for metric, of course. If this was a 1 millimeter pitch, or I guess 1.5 is closer to 0.0625, you'd reduce the diameter by 10% of 1.5 millimeters. So what you've been looking at here is actually the second side, the second handle. I've done the same thing on the opposite side. Again, that was just a bit of an insurance policy. Had I made any bonehead mistakes, I could just move back on the stock. But now that I'm happy with both ends, I can just take the stock and snap it to the length I need. All right, there we have them, the 2 handle blanks. That's extra stock. I mean, technically you could stop right there. The rest of this is just dressing these up. Now I can choke up on these, finish the end, and cut the knurls. The knurls are in, got both parts done, but let me get you caught up. I started off with a small center in the end. Compare that to the one in the original. This is the smallest center drill I have, just enough for me to hold on to cut this taper and hopefully not get much chatter. Then I rounded the ends a bit. I was just going to face that and do a large chamfer. Then I decided to do a full round. And as I set up for that, I just kind of tuned it back a bit and went with just sort of this, I don't know, pillowed bottom. Not sure what you call that. I know, I kind of like it. Gives it that old-timey look. The radius bottom I did with a form tool, just because I happen to have one. But that would be easy enough to do with a chamfer tool. Just get an approximate radius that you like and blend it a bit with a file. The form tool just helps with consistency between the 2 handles. The knurls turned out well. This probably would have looked better with a diamond pattern. Now it's got more of that micrometer barrel kind of look, but hopefully it works out. I'm setting up to cut the taper. What I'm doing here probably isn't strictly necessary. I've mounted an aluminum cutoff, drilled and tapped it for this thread, and I'm going to use that to hold the handles. Would have probably been fine to mount the handle directly in the chuck, but this way I get a little bit further away from it, from the jaws, and I have a pretty close to repeatable position for the next handle. So the taper I cut in the next handle hopefully matches this one exactly. Now I can just come in and seat the tailstock. I've set the compound at an angle. Anywhere between 2 and 3 degrees should probably be fine. I set it to 2.5 because I'm not feeling particularly committal today. And the slide is wound all the way in. I can back it up, but it won't go any further. That's going to act as my stop. With the tool extended as far as it'll go, I'm going to dial it in with the carriage, lock my carriage in place, and cut the taper with the cross slide. This way, hopefully I can't overshoot my mark, and again, both handles turn out the same. And just like that, there they are. Hopefully you can make out I made the new ones a smidge longer, increased the diameter a bit at the end. What I was going for was more of a, I don't know how to explain it, a more accentuated feel in the taper. The changes are subtle, but the new one feels a bit more substantial. I did hit these with some sandpaper, kissed them with a file first just to remove the lathe tool marks. Then I think it was like 320, 600, and maybe 1,000 grit paper. Although the finer surface finish does make them look a little more attractive, I did it more for corrosion resistance. The higher the surface polish, the surface finish, hopefully the more resistant they'll be to rusting basically. Anyway, I'm happy with those. Next up are the jaws. These are the blocks that will become the jaws of the tap wrench. I roughed them out on the mill, and in my case I did surface grind them. That is completely unnecessary, but this piece of scrap out of the bin happened to have two perpendicular faces already ground from some other project. It was just too easy and tempting for me to throw them on the surface grinder and take them to final size. I actually regret grinding these. I did it pretty rough and tumble. You can see that surface finish isn't spectacular. I'm hoping that buffs out, but it might not. Anyway, I've also drilled two of the holes I'll need in the first vice jaw. I'm going to do an identical operation to this one here. That side is drilled and reamed for a slip fit, and this side is drilled to accept a tap to match the thread on the handles. Let me walk you through how I set this up in the vise and indicated them in. That thing you see loaded in the spindle is an edge finder. I'm not exactly sure where that name comes from, but I'm using it to find the edges of my part. As the tip moves closer to the work, the wobble that you see starts to go away. The two parts of the edge finder become more and more concentric until the tip kicks out. When that happens, I know I'm exactly one edge finder tip radius away from the work. I can enter that radius into the DRO or set the scales on the mill handles, and I now have one axis indicated or located. Now, since my part is in the vise, below the top of the vise, and I have no edges to pick up directly, I can just edge find the jaws of the vise. That right there is the 0th law of thermodynamics in action. As it turns out, leaving the part flush wasn't the smartest thing to do, because I can't come in and cut the V-groove now. So this part needs to be picked up again later, do the edge finding again, and drop in that center groove. Edge finders come in all shapes and sizes, inch and metric, but they're not all created equal. If there's one place you shouldn't really skimp, it's with an edge finder. That said, over the years, I've bought my share of low quality ones. I mean, in theory, they're all the same. They have some part of the body or the tip not connected to the shank of the tool. There's just a spring on the inside that sort of holds them together. And the edge finder should be very easy to move, almost like it's on an air cushion. Any grit or burrs or irregularities on those surfaces will affect the edge finding ability of that tool. Of course, if you have burrs on your parts or nicks and bumps you accidentally edge find against, well, that'll throw you off too. But that's not really the edge finder's fault. Edge finding does have some uncertainty to it. Depending on the quality of your edge finder and your technique, often when I'm using an edge finder, I'll come into that surface a few times. I'll try to get a feel for when that edge finder snaps over. But of course, how accurate you need that to be depends on the project you're working on. Now in this case, I'm edge finding all four sides. And I'm using the half function on the DRO to find the center. So the reference point I'm looking for is sort of the 0, 0 mark in the center of that block. And I'm machining all of the features around it with respect to that point. Sometimes you might just pick up X and Y and that back corner might be your 0, 0 reference. But this way, since I'm coming in from two directions with the edge finder, if my technique is consistent, hopefully the edge finder error cancels out. Now, you don't need a DRO to do that. You could just use the scales on your machine. Just edge find on one side, measure how far you have to come over to edge find on the other side and divide that by 2. And there are the jaws. You should have just seen me cut the groove in there. I used a chamfer mill. I cut a larger one in one side and a smaller one opposite that, just in the off chance I need to use this tap wrench for a smaller tap. Those are some nice stress risers. Let's hope using a larger tap doesn't snap this jaw in two. If you don't have a chamfer mill, you can certainly do this with a regular end mill. Just tip the part up at 45 degrees or swing the head over. Come in with a regular flat bottom end mill, but whatever it takes. Compare that to the one I've been working off of. This is the original from the original tap wrench. The new jaws are slightly longer, and the next step would be to round these corners off. Now, a normal person might file those radiuses in or cut them in real slow at something like a belt grinder, but I happen to have one of these. This is a radiusing end mill, or an outside corner radius end mill, I guess the opposite of a ball mill, and it just happens to be the correct radius to round these parts off. Now, in theory, a tool like this cuts an external radius. In practice, however, at least in my experience, they usually just ruin your parts. I prefer to always cut chamfers before resorting to one of these things, but let's try it out together. That looks like a lot of run out on that tool. See if I can tighten this setup a little bit. Bad collet, maybe? Or there's a chip in there. I'm going to take this collet out and clean everything. Oh, I knocked the collet and the collet holder down. Everything looked clean. I've seated the cutter up as high as I could. It's still weeble wobbling. That's not terrible, I suppose. It'll need some cleanup. I'm starting to regret not having done this with a rotary table. It would have been a little bit more setup up front, but would have gotten me a perfect radius and probably a much better surface finish. Let me do the other side and I'll meet you back at the bench. Since last we met, I finished the outside rounds and tapped 2 of the holes. I know you're wondering how I finish the ends, but what you really should be asking yourself is how I tap these threads before finishing the tap wrench. I brought the rounds in with a file and did the finish pass on the surface grinder. Now, how to surface grind rounds is a story for another time, but if I had to do this again, I'd use a rotary table, or the CNC router, or belt sand them, honestly. The radius cutter didn't work so hot, and in editing the video to now, I noticed these parts moving when I was using that form tool. It's probably sped up, but if you go back, you'll likely notice that as I'm making progressive cuts, the parts start leaning further and further in the vise. I also noticed that I lost the tip on my chamfer mill and ended up with a wonky V-groove. There it is. Starts out okay, ends up a little bit odd. Not exactly sure how that happens with a spinning tool, but there you have it. I may clean these up with a square bottom end mill, but I'm noticing the larger taps and screw extractors I'd be using with this tap wrench seem to have chamfered corners and actually still fit fine. But more than likely I'll fix those just on principle. It's kind of funny, I don't see these parts while machining them as clearly as you do. Though it's probably worth leaving a few defects in there, so 150 years from now, some snot-nosed kid can identify this as homemade while they're building a copy for their audience on OneTube. And here they are side by side. I'm not sure if you could readily pick up the differences other than mine is a little bit larger. I changed the aspect ratio of the jaws. I think it looks a little bit better. More importantly, proportionately, the 2 screws are spaced further apart. So when this is opened up to its max capacity, the square end of larger taps fits a bit better. I also like the feel. The handles turned out well. I like the larger diameters on the end and the slightly more aggressive taper. Hopefully this feels nicer when you're spinning your way back out of a tapped hole. You know how you kind of ride your tap wrench with your index finger? On straight-handled tap wrenches, your finger sort of slides off and you lose control. But I don't know. That's some subtle stuff there. And I think that's it for now. Be sure to stick around for the follow-up video where we test this out to see if it acts. I'm just kidding, there won't be a follow-up video. Plus, I already used it to tap the 2 holes in the jaws, so I know it works. But as promised, here is a drawing if you'd like to make your own. As you saw, maybe not much to it. Fun project, and there's a lot of room to make your own tweaks. Customize it. Maybe make a nice one for your special someone. There aren't a lot of things that tell a person just how you feel about them, like a custom tap wrench. You can scale it too, of course. Make a larger one, or maybe a smaller one. Maybe you don't like that person all that much. Anyway, I really enjoyed your company. We should do this more often. Thanks for watching.